Welcome back for part 3 of Find the Percent of a Number. We're on resource 10 of 13. We're closing in on it. Just a little bit more to go. What is 0.25% of 58? Why might it not be advantageous to use a bar diagram for this one? Well, simply put, it'd be really hard to take and break it down. The 0.25%, that's a teeny tiny piece of 100%. So, I mean, how are we going to put all that on a bar diagram? And on top of that, how are we going to make 58 into equivalent little pieces? It's just not going to work. Bar diagram, not a good choice. So instead, what do they suggest we use? Well, we're going to start off with identifying our parts. The part is going to be the unknown. That's what we're looking for. The whole is going to be 58, and our percent is going to be 0.25. Check those. We got that part good. Let's keep moving. Now we're going to use a ratio table to move through the slides to see how we can do this one. For this, we're going to take and go all the way back to just 1%. So we're going to divide the top and bottom by 100, and that is going to give us 1% of 58 is going to be 0.58. But we don't want 1%, do we? What do we want? We want 25 hundredths of a percent, 0.25%. What could I do to 1 to get it back to 0.25? I could divide it by 4. And if I do it on the top, yeah, I have to do it on the bottom. And yeah, that division's going to really stink. But when you divide the 0.58 by 4, that's where the 0.145 comes from. Pretty simple, isn't it? Ratio table, that's a real good option for this one. What other options do we have? Well, we could use equivalent ratios, and that would be another really good option to use. And let me take a screenshot of this so we can see how it would work. So we have our ratio table set up, and we have to ask ourselves, what can we multiply, whoops, get my marker going, what can we multiply 100 by to get it to equal to 58? And the answer is going to be 0.58. If I do it on the bottom, I have to do it on the top. So now we're going to do the same thing, 0.25 times 0.58. Of course, we need to do some grunt work from that. We're going to take and set it up 0.25, 0.58, do our multiplying. 8 times 5 is 40. 8 times 2 is 16, plus 4 is going to be 20. 5 times 5 is 25. 5 times 2 is 10. Plus the 2 is going to be 12. We're going to add those up, 0, 5, 2, 1, and we're going to bounce our decimal, 1, 2, 3, 4, 1, 2, 3, 4. So the answer is 0.125. So you can say now that n is equal to 0.125, which is the same exact answer we came up with the other way. So we can go here, 25% of 158 is going to be 0.125. Make sure you're putting your 0 in first. Uh-oh, what did I do wrong? I did bad math. It should actually be 0.145. Not sure where I did my bad math mistake at, but obviously somewhere over here I added bad or something. Oh well, get over it. Now let's think about this. Compare the part 0.145 to the whole 58. Does it make sense that the 0.145 is a whole heck of a lot less than 58? Yeah, because we're dealing with 0.25% of it. We're dealing with less than 1%, a teeny amount. So absolutely it makes sense that we're going to have a much, much smaller number. Now it's time for you to solve a problem. You get to use any method you want to come up with the answer to this. Pause your recording so you can solve this problem, please. So, we want to find out what 0.35% of 250 is, and I've set it up as equivalent ratios here. So first thing I'm going to ask myself is, what do I have to do to 100 to get it equal to 250. And the answer to that is, of course, going to be to multiply it by 2.5, and that's going to give me the 250. If I do it on the bottom, I have to do it on the top. 0.35 times 2.5. We're going to multiply that out. 0.35, 2.5, and we multiply. 5 times 5 is 25. 5 times 3 is going to be 15, plus the 2 from the 25 is 17. 2 times 5 is 10. 2 times 3 is going to be 6, plus a 1 from the 10 is 7. Add those up. 5, 7, 8. Bounce, bounce, bounce. Bounce, bounce, bounce. So our answer, n, is going to equal to 0.875 for our answer. Come back over to our web page. 0.875. Click check the answer. We have success. Now it's time for you to do an apply problem. Remember, in the apply problems, you got lots to do. Read your question multiple times, write down what strategies you're going to use, and then solve the problems. Afterwards, write about it. Write an argument to defend your solution. Pause the video and work on this. Alright, let's take a look. Students were asked which night they planned on attending the book fair. The results of the survey are shown in the table. 20% of the students planned to attend on Wednesday, attended on Thursday instead. That sounds like it might be important, so I'm going to highlight it. 25% of the students who planned to attend on Thursday attended on Wednesday instead. So that sounds pretty important too. So let's take and highlight that. Which day, Wednesday or Thursday, had the greater actual attendance? My gosh, this is going to be a brutal problem. Alright, I think a ratio table is going to be the best way to solve this problem. So I've set up my two tables. One shows Wednesday to Thursday. Yes, that's an H, because you're going to find when you grow up that they have Mondays M, Tuesdays T, Wednesdays W, and Thursday is H. Weird, I know, but I guess T was already taken. So my percents that I'm working with, I have a 100% and a 20% is my starting out points here, right? And I know that 100% of the students that planned to attend on Wednesday was going to equal 270. But alas, those numbers don't work real well there, so let's do and move everything over. There we go. That's going to do a little better. Let me take and move my stuff down just a little so I have some more room to work, and now we are ready to go. Now, I need to get to 20%, but I can't divide 170 both by the same number to get down to where I have 20% there. So I could take and say, well, actually, yeah, I could. Let's do that. I'm going to do 100 divided by 5 is going to give me my 20%, and then my 70 divided by 5, and that's going to end up giving me 10, 11, 12, 13, 14. So 14 students who planned to go on Wednesday actually went on Thursday. And now we're going to do the same thing for our Thursday to Wednesday group. I've got my 100%, and then I ended up having 25% here as a goal. This other column we're not going to need. 100% of the kids who planned to go on Thursday was 112. Take and say, well, 100 divided by 4 is going to give me 25. 112 divided by 4, therefore, is going to end up giving me, well, that's going to be 25 plus 3 is going to be 28 to go right there. So now we can say that 28 students moved from Thursday to Wednesday. That's just the beginning of solving this problem. Now we're going to have to take and do some other cool math here. We're going to start off with Wednesday, where you had 70 kids scheduled. Let's make that a little bit bigger here. We had 70 kids scheduled to go on Wednesday, but of those 70 kids, 14 of them decided they were going to go on Thursday instead. So we're going to take that 70 and we're going to subtract the 14 that decided to go on Thursday, and that is going to leave me with 56 kids. Next, we have 28 kids that were going to go on Thursday that decided to go on Wednesday. So we're going to add 28 there, and now we can say that our new Wednesday totals are going to be 50, 60, 70, 84 people showed up on Wednesday. And I'm going to put a big old W here for Wednesday. On Thursday, you had 112 students that said they were going to go on Thursday. But of those, 28 decided, you know what, forget Thursday, we're going on Wednesday instead. So come off to the side, do a little bit of grunt work. My brain is tired. We're going to do some borrowing here. That's going to become a 0 and a 10, so 12, that's going to be a 4. 10 minus, it would be 84 students right there. 84, 112 minus 28 is going to give me 84. And then we have to take and add to that the 14 kids who were going to go on Wednesday but are now going on Thursday. Are you following me? Told you this one was brutal. That is going to end up giving me 84, 94, 98 students that showed up on Thursday. With that, we're ready to answer the questions. Which day, Wednesday or Thursday, had the greatest attendance? Well, that's going to be Thursday at 98. And by how many students? 98 minus 84 to get our final answer here is going to end up giving us 14 students more attended on Thursday. Let's see if I am right. We're going to go back to our computer page, which is right here. We're going to scroll down. I'm not going to do the how I can do it time because I want y'all to be able to get busy doing homework. I said more kids went on Thursday. Isn't that what I said? Yep, more kids went on Thursday. By how many? 14. Check our answer. We did it. We had success. And that problem was so much fun, I'm not even going to make you do the next one because it'll probably be just as brutal as the last one, and I'm not going to be that mean to you. Get busy on your homework. When you're done with your homework, when you're doing your homework, make sure you're showing me good quality supporting work. Without good quality supporting work, I cannot give you good quality grades.